In this episode, we're going to do an IPv4 access control list implementation challenge. I'll show you how to do it, and we'll talk about the concepts along the way. In this activity, we will configure extended standard name and extended named ACLs to meet specified communication requirements. We'll be discussing configuring a router with standard named ACLs, extended named ACLs, extended ACLs to meet specific communication requirements. We'll configure an ACL to control access to network device terminal lines. We'll talk about configuring the appropriate router interfaces with ACLs in the appropriate direction. And then finally, verifying the operation of the configured access control list. Greetings to my tech heads out there in the KevTechify nation. And if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Packet Tracer Lab 5.5.1 IPv4 Access Control List Implementation Challenge. I have the Packet Tracer Lab opened up here. On the left side, I have our topology, our work area. This is where we're going to be doing our work, looking at our devices. On the right side, I have our instructions. On the very bottom right, I have the Packet Tracer activity window that opens up that has the instructions in it. In the upper right, the majority of the right side, I have the Word document of those same instructions. The reason I have the Word document is we have several questions we need to answer. This will allow me to type my answers in and save those answers. Looking here at our network, we can see that we do have a more complex network. And here we have two routers that we are using. These two routers are on our network. These routers are connected by a WAN connection. HQ has a connection to the internet. Out here, where we have a web server, we have an internet user connecting in. And then we do have some internal networks. HQ has HQ LAN 1 right here. Then we have HQ LAN 2, which is sort of the bottom left, both coming off the HQ router. The branch router right here has two networks coming off. One here is branch LAN 1, and then we have branch LAN 2. And so this makes up our network, and we're going to look at using access control lists to allow access to different parts of our network. Here's our addressing table. It has our devices, the interfaces, and what their IP addresses and subnet masks are. Coming down here, we have our objectives. We're doing a lot with ACLs, standard, extended, configuring them, configuring the appropriate interfaces, and then we're going to verify the operations. Instructions. Step 1, verify connectivity in the new company network. And so this is our new company. That's, I think the name of our company is New Company right here. And then verify connectivity. All hosts should be able to ping all other hosts. Now, we do have a whole bunch of PCs and a bunch of servers. The approach I'm going to take is I'm going to jump on PC 1 here, and then I'm going to ping each of the other devices in our network. And because I can ping one way to the other, that's going to show two-way communications. But when I'm able to ping PC2 and PC3, because I can ping both of them, I'm going to make the assumption PC2 and PC3 can ping each other. Now, in a real world, you may want to go in and just confirm that all those devices, all those locations can ping each other. For our lab, that's what I'm going to do. Is I'm going to take PC1 and just ping all the other devices on our network. I'm going to click on PC1 here, bring it up, open up my command prompt, scroll up to my addressing table, and I am going to just start here at the top, work my way through. Branch and HQ here are two routers. We're not going to be concerned with pinging those addresses because we're going to ping through those. And then I'm going to start looking at our devices down here. I'm on PC1, so I'm going to start pinging PC2's address and just work my way through the list. And so the first IP address I'm going to ping right here is 192.168.1.20, which is PC2. So go ahead and type in ping and 192.168.1.20. I actually put a space in there. There we go. I can ping PC2. Go ahead and ping PC3. Has an IP address of 192.168.1.30. So ping 192.168.1.30. I spell the word ping correctly. I can ping PC3, so PC1 to PC3. Now let's go ahead and ping admin 192.168.1.67. So ping base 192.168.1.67. Looks like we are transferring networks, so hopefully we're doing an ARP lookup here. So the first one failed because it was doing an ARP lookup. Next three worked. I'm just going to repeat that to make sure it worked correctly. All four are working, so that we can ping admin. Let's go down, ping the next one. The next one here is the enterprise web server with an IP address of 192.168.1.70. Let's go ahead and ping that. So ping 192.168.1.70. Probably have to do an ARP lookup here again. Time out the first ping. That's what's happening. So first one failed, next three worked. I'm going to repeat that command, up arrow enter, just to verify all four are working. And if you notice, I hit enter between them, because that way if I have to scroll back, I can easily see, well, this was this device altogether, because I do have some clear enters here. And so by default, I just hit enter a couple times to give me a couple clear spaces so I can go on and ping my next one. So that was the enterprise web server. Now we're going to ping the branch PC 192.168.2.17. So ping 192.168.2.17. Most likely we're doing an ARP lookup again, so the first one will fail. Repeat that command to make sure all four work. And so we were able to go from PC1 to branch PC. That looks good. Then we are going to try the branch server. Branch server's IP address is 192.168.2.45. So we can go ahead and type ping 192.168.2.45. Once again, probably doing ARP lookups. That's what it looks like it happened. First one failed, next three worked. I'm going to go ahead and repeat that quickly just to make sure all four worked. And so we are able to ping from PC1 to the branch server. Now we're going to ping to the internet user, which is 198.51.100.218 address. Go ahead and ping that. So ping 198.51.100.218. Okay, hopefully we're doing ARP lookups. That's looking like what we did. I'm going to repeat the command. All four are working. So PC1 to our internet user work good, and then let's go ahead and ping our external web server at 203.0.113.73. So ping 203.0.113.73. Probably are doing an ARP lookup. Looks like what happened. First one failed, next three working. I'm just going to go ahead and repeat that, make sure all four are working. So because we could ping everything in our network, I'm going to say we have full connectivity. Step one is done. On to step two. Configure standard and extended ACL per the requirement. Configure ACLs to meet the following requirements. Okay, some important guidelines. Do not use explicit deny any statements at the end of them. So at the end, make sure we don't type in deny any or deny any at the end of any of our ACLs. We're not going to do that. Use shorthand whenever possible. So use the word host or any whenever possible. Write your ACLs to address the requirements in the order that they're specified. So for each ACL requirement, do each bullet point in the order. And then finally, place your ACLs in the most efficient direction and location. Now, when we think about our ACLs, the direction and location, standard access control lists go as close to the destination IP address or network as possible, so as close to the destination. Extended, where we can filter on source, destination, port numbers, we put that as close to the source as possible. So standard, which only looks at the destination, the source IP address, source network, that goes as close to the destination as possible. And then extended goes as close to the source as possible. ACL1 requirements. Create ACL 100. Explicitly block FTP access to the enterprise web server from the internet. Then we're going to do no ICMP traffic from the internet should be allowed to any of the hosts on the HQ1 LAN, and allow all other traffic. So creating a numbered extended list, because once again, extended numbers go from 100 to 199. So this is an extended. And so how we do that is as we control or create our access control entries, that creates on the first one, that creates our access list. And so explicitly block FTP access to the enterprise web server. So the enterprise web server is here from the internet, and this is the internet here. So any traffic from the internet destined to here on FTP, we're going to block it. So that means we're going on the HQ router, and that's where we're going to go ahead and create our access control list. I clicked on the HQ router, make the window a little bit bigger, going left to right, hit enter here. No password set up, so we can go ahead and type enable. Brings us into privilege exec mode. From here, we are looking at configuring our ACL, so we need to be in global configuration mode, so it's config T. Now, we are looking, I'm going to scroll this down here, so our requirements are shown here. I'm going to slide this window over so we can see our diagram. Explicitly block FTP access to the enterprise web server from the internet. And so any traffic from the internet, we're going to block to this specific host on port 21. We're going to block FTP. Okay, so creating our list here. First thing we got to do is start off with the keyword of access-list. That says we're going to create an access list. Make sure you spell the word access right. That's turning out to be my personal kryptonite. And so access-list, and we're creating a numbered one here. So we put the number in. Once again, we're using access control list 101. And we're going to be denying, because we're denying FTP traffic. So it's a deny. And then what protocol are we blocking? Well, we're blocking the TCP. We're actually blocking FTP, and that's part of TCP. So we can deny TCP from anywhere. So from the internet, from anywhere. So we can use the keyword any, because that was one of our guidelines. Use the keywords when possible. And then destined for this device right here. So we can actually use the keyword of host now. So host, and then the IP address of our enterprise web server, which happens to be the IP address is right here. Our IP address is right there. So we can go ahead and type that in, 192.168.1.70. And then we specify exactly which layer 4 port are we looking at. We're looking at filtering FTP. So it is equal to, and we could either put 21 in here, or it said use keywords when possible, even though it said host and any. FTP is a keyword that is equal to port 21. So I'm just going to go ahead and type FTP. So our command looks like access list 101 deny TCP any host 192.168.1.70 equal to FTP. So that is our first access control entry in access list 101. That takes care of our first bullet point. Then we have to go down and look at our no ICMP traffic. So no ICMP traffic from the internet. So once again, we have the internet here. From the internet should be allowed to any host on the HQ LAN 1. That's taking ICMP traffic from the internet, and we want to deny it. So not allowed here to HQL LAN 1. Okay, so it's still part of access list 1, so it's access-list, and then our number 101. And we are denying here. We're not allowing traffic through, so it's a deny. Now this time it's ICMP traffic and not FTP or TCP traffic, so we can put in ICMP right here. From anywhere on the internet. And so we're going to say any here next. And our destination is this network here, our HQ LAN, which is this network address, 192.168.1.0/26. Okay, so we type in our network address here, 192.168.1.0, and then we put in our wildcard mask. A /26 is 26 ones followed by 6 zeros. To go from the subnet mask to the wildcard mask, you invert those numbers. So now we have 26 zeros followed by 6 ones. You convert those 6 ones plus 2 zeros, that gives us that last octet, into decimal. That is a .63. So our wildcard mask is 0.0.0.63. So we can enter that in here after our network address. 0.0.0.63. Because we're blocking everything in the ICMP, we're just going to hit enter. So that takes care of this other requirement, and then we have to allow any other traffic. So if it's not denied by this first one, it goes down to the second one. If it's not denied by the second one, it'll go down to our permit any statement. And so to put that in there, it is access-list. Can't spell access right. And then we're still on access list 101, and we're going to permit. We're permitting anything, and we have to specify the protocol. We're looking at the IP protocol. And at this point, is the destination is anywhere on the network, and the source is anywhere on the network, and then our destination is any. So our statement is access list 101 permit IP any. It'll allow any other traffic through that isn't denied by the first 2 access control entries. Go ahead, hit enter in that command. That should take care of all of the requirements for that access control list. Now we have to place it. Well, it's on HQ1 because that's where we are looking at filtering the traffic. That was kind of the connection point between those. And where are we going to place it? Now, because we're filtering traffic on HQL LAN 1 and HQL LAN 2, we necessarily can't put it on either one of those interfaces. So we can't put it on this Ethernet interface or this Ethernet interface. Traffic is coming from here. That leaves us this interface right here, this serial connection. Now, how do you find out what it is? I'm going to go ahead and click in this window, anywhere in this window, make sure it's active. Then I'm going to mouse over this triangle, and it's going to say this is serial 010. So we need to apply it on this interface. And as we set up our ACLs, all the source traffic is here, destined for this traffic here. And so the traffic is traveling from here, from the top to the left. Once again, traffic is traveling from the top to the left. So the traffic, we're looking at traffic coming inbound on that serial 010 interface. To apply it, let's go back into HQ here. We need to go into the interface. So once again, that was serial 010 interface. So we can type in interface space serial 010. Now we're in that configuration of an interface mode. We can tell by our prompt, and now we can apply that access list. That gives us IP space access dash group. How I play that in my head, it's a group of access control entries. And now you'd either specify the name or the number. We are doing a numbered one, so it was number 101. And once again, we are applying it to the end traffic because we're going from the internet, which is the top, to the left. And so to go through that router on that interface, that would be the inbound traffic on serial 010. So our direction is in. Should I have that right? Oh, I spelled access wrong again. And that applies access list 101 to the inbound traffic on serial 010. That takes care of all of our requirements here for access list 1. Down to access list 2. Access list 2, we're using the number of 101, so we're creating another extended list. No host on the HQ LAN 1 right here should be able to access the branch server. Here's the branch server. Whoops. Here's the branch server. So no devices from HQLAN 1 should be able to access the branch server. Now we're doing the extended list. We can tell it's extended from our range here. 111. Extended range for numbers is 100 to 199. So this is an extended one. Extended is placed as close to the source as possible. So when we look here, as close to the source as possible, we're going from here to here. This is the source. So we're going to place our access control list on the HQ router again. We're going to build our access control list there. Looking at the requirements again, and then we allow all other traffic. And so we're going to place that traffic right here, as close to the source as possible. Now, when we look at that, we also look at what interface are we going to do it. So it's going from HQLAN 1 here, the upper left, to branch server, which is the bottom right. Place it as close to the source as possible. That means it would be this interface right here. This interface, how do we tell what interface that is? I click in this window to make sure it's active, then mouse over this green triangle, and it says we are at gig 000. So let's go ahead and create our access list 111 and apply it. I'm going to go ahead and click on the HQ router. We are still in the configuration of an interface, so let's go ahead and type exit. Brings us back to global configuration mode. From here, we can start entering in our access control entries into our access control list. We start that off once again by access-list. We're using the number 111 at this time. Oh, I gotta spell the word access right. I apologize. So access list 11. And we are looking at denying traffic. So we're going to deny traffic. We're going to deny the IP suite here. And our source here is any, because we are on this router here. We're on this router, so any traffic, and we're going to apply it right here. So we're going to deny any traffic coming into this interface. And so we don't necessarily have to specify a network address. We can use the shorthand of any because we are applying it right here. If we are applying it to a different interface, then we might not be able to use any. But because it's going to be applied right here, placing it as close to the source as possible, we can apply it to any traffic because it's only HQ LAN 1 traffic. So we can use the word any. So after IP, we put the word any. And then our destination actually is just this device right here. It is this device. So we can actually use the keyword of host at this point in time. We can use the keyword of host and then put the IP address of the branch server in there. The branch server IP address is nicely labeled right here for us, so we can go ahead and type that in, 192.168.2.45. Seeing as this is the first access control entry, this creates the access list and puts that access control entry in that list. That was the deny statement. Then we have allow all other traffic, and this is where we have the permit any. To do that, it's access dash list. Once again, we're using 111 as our access list. We're going to permit, and this is where we say permit any at this point in time. So permit any. We're going to permit any traffic through there. Oh, I forgot to tell it what protocol we are looking at. We're looking at the IP protocol. So our statement comes out to be access list 111 permit IP any. Then the next step, we've taken care of our requirements. Now we need to apply it. Once again, we're going to apply it to this interface right here because it's as close to the source as we can get it. I mouse over it, and this is gig 000. So let's go into the gig 00 interface. So interface gig G000. And now we can go ahead and apply that. To apply it, it's IP space access dash group. And then the number of it, once again, we are using 111. And then the direction, this is the interface right here. We're filtering traffic from this LAN to this interface. So traffic from this LAN to get over here would have to go on the in direction of this port. And so it's the direction of inbound traffic. And of course, I spelled access wrong. And that applies access list 111, which is an extended list, to the inbound traffic of G000. Access list 2 is done. Onto access list 3. Access list 3 requirements. Create a named standard ACL. Use the name VTY_block, all lowercase. Once again, case sensitive and punctuation sensitive, so make sure you name it exactly right, or Packet Tracer isn't going to score correctly. The name of your ACL must match this exactly. Only addresses from the HQ LAN 2, so this is HQ LAN 2, should be able to access the VTY lines of the HQ router. Should only be able to access the VTY lines on HQ. Okay, so we have to remember how to look at blocking access to the VTY lines. That we have to define our access control list. It's going to be a standard one named VTY_block. We have to permit the traffic from the HQL LAN, and then we have to apply that to the VTY settings on the HQ router. So I'm going to click on our HQ router here. We need to be in global configuration mode to start, so I'm going to type in exit, and then I hit enter a couple more times just to make sure I have a clean working area. So if I have to scroll up, I can see where my groups of text are, so I can go back and easily identify what I typed in. And so the first one here is we have to do a named access list. This is where we have to create the named access list. Once you create it, you go into the configuration and you can add your permit statements into there. So creating our named standard access list of VTY_block. here from global configuration mode, we start off with IP and then access-list. And then right here, we say, is this a standard or extended? First, I need to spell access correctly. This is turning out to be ridiculous. And now, so we have IP access, and now we need to either say standard or extended. We're doing a standard one, so we can put in the word standard. And because this is named, then we put in our name. And once again, it is case and punctuation sensitive to be scored correctly in Packet Tracer. So these are all lowercase letters, so it's VTY underscore BLOCK. Make sure I spelt that correctly. As soon as I hit enter, notice my prompt has changed. We are in global configuration mode. Now we are configuring a standard, and it says NACL, Named Access Control List. And this is where we can put all of our remarks, our denies, and our permit statements in here. And so what we're doing is we're allowing addresses from the HQ LAN 2, so from this network, which this is the network address right here, 192.168.64, and it's got a /29. /29 is 29 ones in the subnet mask. So we got 29 ones followed by 3 ones. You go from the subnet mask to the wildcard mask, you invert that, that gives us 29 zeros followed by 3 ones. So you break it up into octets, that gives us 0.0.0, and then we have 5 zeros and 3 ones. Convert that into decimal, you got a 1 plus a 2 plus a 4, that's a 7. So our wildcard mask is 0.0.0.7. So let's go ahead and put our permit statement in here. So it's permit, then our network address of 192.168.1.64, and then our wildcard mask, once again, that was 0.0.0.7. That is our permit statement from HQL LAN 2. And that's all we have to do. Those are all the permit or deny statements, all the access control entries in our VTY block named access list. Once we're done configuring that, we go ahead and type exit. That will bring us to global configuration mode. Now we need to apply this to the VTY terminal. We do that by going into our VTY lines. And so from global configuration mode, we can go ahead and type in line VTY 0 to 4. Hit enter. Notice our prompt is now changed from global configuration, that we are now configuring our line. That's what we want. And here, this is where we have to apply that access list to this interface. The command we use here is access dash class. So access class, then the name of our access list, once again, all lowercase, VTY underscore BLOCK, VTY underscore block, and then what direction. Because we are looking at traffic from HQL LAN 2 into router, it's on this interface, right? It's coming in here, but it's not much. So this is the traffic coming into this router is what we're looking at. So our direction here is in. Our command here is access class VTY underscore block in. We apply that. That takes care of requirements for access control list 3. On to access control list 4. First one here is create an extended ACL called branch underscore to HQ. So from branch to HQ. The name of your ACL must match exactly. Once again, we are all underscore, or we're all lowercase with 2 underscores. No host on either the branch LANs. No host on either of the branch LANs, and this here are the 2 branch LANs, should be allowed to access the HQ LAN 1. So this LAN right here. use one access list statement for each of the branch LANs. So we're going to create two access control entries, access control statements, access list statements, where this one, branch LAN 1, will be blocked from accessing HQL LAN 1. Then we're going to create a second access control entry where we're going to block traffic from branch LAN 2 to our HQL LAN 1. Now we are doing an extended one. Extended ones get placed as close to the source as possible. Well, first we got to pick out what router we're looking at. As close to the source as possible. Is it the HQ router? Oops. Is it the HQ router or is it the branch router? Well, the branch router definitely gets us closer to our branch LAN, so it goes on this interface, or sorry, this router. Then to apply, because we're going to have both of these in one access list, we can't apply it to either one of these gigabit interfaces, because if we apply that one access list that is blocking both LANs to either one of these interfaces, the other LAN would be able to go through. So what we have to do is place it on this interface right here, as close to the source as possible. Can't do these interfaces, because if you put it on one or the other, it would block traffic on that LAN, but it would allow the other one to go through. So we have to do it on this one. And that would be, and I clicked in the window here, I'm mousing over the triangle, that would be serial 011. And then that would be to the traffic on what direction on this interface. It would be going out of the router, out of the serial 011 interface. So it would be on the outbound traffic. Oh. Okay. And then all other traffic should be allowed. That means then we have a permit any in there. So we're going to create an access control list here on branch. I'm going to go ahead and click on branch. Make sure on my CLI tab, make this window a little bit bigger. I'm going to slide this over. Hit enter, enable to get into privilege exec mode. Then when we're dealing with configuring our ACLs, we need to be in global configuration mode. So go ahead and type in config T. First thing we have to do is we're doing a named extended ACL. So we have to define that. We have to create that. We start off with IP space access list. And then we say either standard or extended. And so we're doing an extended one here. So go ahead and put the word extended. So you spell it correctly. And then the name of it. Once again, it needs to match exactly what they give us. If it doesn't match, Packet Tracer isn't going to score it. So make sure it's branch _to _HQ. And it's all lowercase. So BRANCH _TO _HQ. I'm going to take a second, make sure I have it in there correctly. Looks like I do. I'm going to go ahead and hit enter. My prompt has now changed. I am now configuring an extended named access control list, extended NACL. So we defined it. We gave it a name. Now we can go in and configure that named ACL. We have to create two statements. One that'll block traffic from branch LAN 1 to the HQL LAN 1. Okay, so starting off, we are denying. So I meant to say we're denying from branch LAN 1 to HQL LAN 1. And then the second statement will be denying from branch LAN 2 to HQL LAN 1 again. So we start off with the deny statement. We are looking at the IP protocols. Then we are saying our source addresses, and seeing as we're doing a network, this is our network address here, 192.168.2.0/27. So let's go ahead and put in our network address, 192.168.2.0. Then we need our wildcard mask. We have the subnet of a /27. You take the /27, write it out in decimal. You convert it, and then you switch the zeros and the ones, convert it back into that. That gives us our wildcard mask. After you do that, our wildcard mask is 0.0.0.31. So that is our source network with its wildcard. And now we put in our destination network. And our destination is HQL LAN 1. Right here is our network address, 192.168.1.0/26. So let's go ahead and put the network address, 192.168.1.0. In a /26 address here, when you convert that into a wildcard mask, that gives you 0.0.0.63. 63. So let's go ahead and type that in, 0.0.0.63. Looking at my statement, just making sure it looks right. That looks good. That takes care of blocking branch LAN 1 from HQL LAN 1. Now we need to create another statement that blocks branch LAN 2, all the devices on branch LAN 2 from HQL LAN 1. Now, very similar to the statement we just entered, except our source network address changes from this 192.168.2.0/27 to 192.168.2.32/28. And so this is the network address here, and then we have a /28. /28, when you convert it into a wildcard mask, turns into a 0.0.0.15. So it's going to be identical except for the source network and wildcard. So we are denying IP traffic, and then from 192.168.2.32, and then our wildcard mask with a subnet of /28, that turned out to be 0.0.0.15. So 0.0.0.15. So that's our source. Now we need to say our destination, which is the same from what we just did up above in the previous ACE. So we can just go ahead and look at that information, and we can type that in there. That gave us 192.168.1.0 to 0.0.0.63. That takes care of this requirement right here. No hosts on either of the branch LANs should be allowed. And then all other traffic should be permitted. Now we can do a permit here. Permit IP, and then any. It'll allow any traffic through there. We've created it. We have all of our access control entries in there. Now we need to enter or exit out of our configuration of our extended named access control list. We can go ahead and type exit. Brings us back to global configuration mode. Last step we have to do is now apply this to the interface. Once again, we are on the branch router, and we can't apply it to either one of these Ethernet interfaces here. We have to apply it to the serial interface. By clicking this window mouse over the triangle, it is our serial 011, and it'll be for outbound traffic there. So let's go ahead and get into our serial 011 interface. So interface of serial 011. Let's apply that access list we just created, that extended named one, to this interface for outbound traffic. And so it's IP access dash group. Then we put in the name or number. We did a named one, so once again, make sure you spell it correctly. It's branch _2 _HQ, all lowercase. So BRANCH _TO _HQ. And then our direction is the out direction. That applied that interface. That takes care of access control list number 4. Step 2 is done. On to step 3. Let's verify our operation. Perform the following connectivity tests between devices in the topology. Note whether or not they were successful. Note, use the show IP access list command to verify ACL operation. Use the clear access list counters command to reset the match counters. And so we're going to do show IP access list. It'll give us a list of all of our access control entries, but it'll also give us any matches that have occurred. That way we can see that it has been successfully, the ACL has been working successfully. So send a ping from branch PC to the enterprise web server. So from branch PC to the enterprise web server, we're going to ping from branch PC to the enterprise web server. Was it successful? So I'm going to open up branch PC, open up our command prompt, and go ahead and type and ping our enterprise web server. So ping, and then they're nice enough to give us the IP address right here, so we don't have to scroll up to the address table. And ping 192.168.1.70. The ping was successful. Okay. So was it successful? Yes. And then explain it. That had to do with the ACL that's permitting the ICMPs through. And so that there was an ACL that permitted those pings to go through. So ACL permitted ICMP traffic through. Which ACL statement permitted or denied the ping between these two devices? List the access list name or number, the router on which it was applied, and the specific line that the traffic matched. Okay, so I'm going to minimize the branch PC window here. We're looking for the one that did ICMP traffic. ICMP traffic, blocking that is part of the extended set. We can't do it with a standard one. So we're looking for an extended ACL. Extended ACLs go as close to the source as possible. So let's look at the branch router first, because that's where the branch PC was. That's as close as we can get to it. Let's go ahead and look at that. I'm going to slide this over. I'm going to hit enter. And I am going to do a show space access dash list command. So show access list. Spell access correctly. Here's the extended list on our branch router here. We have the first two entries are denies, but then the last one here, this 30, is a permit anything. And this is what let the pings go through. We're permitting it right here. Sequence number 30. And so list the access list name or number. So it was branch underscore 2 underscore HQ. And what router was it on? It was on the branch router. And the specific line that it was, so it was branch to HQ ACL on the branch router. Okay, we need to clean this up. Autocorrect here gave me a capital B on my ACL name. I'm going to make it lowercase so it's technically correct because it is case sensitive. So branch to HQ on branch router, and then that was sequence 30 or last ace. Attempt to ping from PC1 on the HQL or HQ LAN 1 to the branch server. So ping from PC1 to the branch server. So here's our source, here's our destination. Was it successful? So I'm going to click on PC1 here. I'm going to ping the the branch server IP address, which is given to us right here so nicely, which is 192.168.2.45. And it's coming back and saying destination unreachable. With how fast it came back right away, it's saying that, to me, that says there's an ACL that's blocking it. It's not timing out. It would have taken much longer to do that. It came back right away. And then it's also saying the reply came from 192.168.1.1. And so if we look here, that's actually an IP address right here on the HQ router. That'll give us a hint on where that access control list is. So was it successful? No, it was not successful. Then we explain, no. And then because it was blocked by an ACL. Which ACL statement permitted or denied the ping between those two devices? I said that it gave us a hint right here on that, and it was on this device, so I'm willing to bet it was right here. So I'm going to click on the HQ router. I'm going to take us back to privilege exec mode, and I'm going to do this show access lists command. And here we have 3 access lists. We have an extended IP one with a number of 101. We have another extended one with a number of 111. And then we have a third one that's a standard with a name of VTY_block. Now we can see that there's only one here that has a match. Only one has a match here. So which statement permitted or denied that? That would be statement 10 of access list 11 on the HQ router. So which ACL statement? So ACL number 111 sequence 10 denied the traffic. It denied all traffic, so we weren't specifically looking for TCP or ICMP. We denied everything with that one. Okay, open a web browser on the external server and attempt to bring up a web page stored on the enterprise server. Okay, so I'm going to minimize the HQ router window here. I am on our external server. So right here, our external web server. Bring up a web page. On the enterprise web server. Okay. External server on the enterprise. So on this server, bring up a web page from the enterprise web server, which is on the internal of our network. So on the external server, bring up the enterprise web server web page. So I have the external web server here. I make this window a little bit bigger so I can see the web browser app here. I click on it, opens it up, and then we put in the IP address of our enterprise web server, which is right here. So we can put that IP address in there, 192.168.1.70. And it brings up our wonderful page right here. Nice and simple, but it shows us it works. So yes, we were able to browse our web page. Now we have to explain it. So the external server, it can access a web page on the enterprise web server. HTTP traffic is not blocked to the enterprise web server, so it's not blocked. So traffic from external server to enterprise web server is not blocked. Which ACL statement permitted or denied the ping between these two? Well, let's go and look here. Now, this, I'm going to minimize our external web server window. Between the external web server and the enterprise, there's only one device where we could put that ACL. So it's on the HQL router someplace. We did our show access list here. I'm going to slide this over. And so we're looking for one that allowed us to go through. Here in our access list 101, we're denying traffic from this network for TCP of FTP. We're denying ICMP traffic, and then we're permitting anything to go in there. So 101, it permitted anything. Looking at 111, we're denying any traffic destined for an IP address of 192.168.2.4. So that's not it. So it could be this statement here, or permit IP any. In the standard ACL, we're permitting traffic from the 192.168, where our external server is on a different IP address. So that's not it. So it's one of these two. It's either 101 or 111. Now, what we're looking at is traffic coming here. We did apply an access control list right here on this interface. So let's go ahead and check out what is applied to this interface. And that'll be what's filtering our traffic. Or filtering or allowing our traffic to come through there. So I'm going to click in this window, mouse over this triangle, and it's going to say this is serial 010. So let's go ahead and take a look at that. So from here, we can do a show IP interface, and then serial 0/1/0 gives us some information. Here gives us our name, we're up and up, gives us our IP address, but then down here it is saying our outbound access list on serial 010 is not set, but our inbound list is access list 101. And so that's what's filtering it out, because if we go up here and look, access list 101 here, we're denying FTP to our enterprise host, but we're allowing web traffic through. We're sequence 20, we're denying ICMP, but once again, web traffic is a TCP protocol, so it's not rejected by sequence 10 or by sequence 20. It makes it down to 30, and then is permitted to go through by sequence 30 here in access list 101. So which ACL? So it is sequence 30 in ACL 101 on, what is that, the HQ router. That's the statement that is allowing us to go through. Okay, on to B. Test conditions to an internal server from the internet. We're going to test our connections to an internal server. So anywhere here is an internal server. And then from the internet. From the internet, we're going to do that. From the command line on the internet user PC. So this is the internet user PC. Attempt to make an FTP connection to the branch server. This is the branch server down here. Is the FTP connection successful? So let's go ahead. Open up our internet user PC. Open up my command prompt, because that's where we're going to do our FTP client. So we'll go FTP, and then we are going to the branch server. Right here is the IP address of that. So we can type in 192.168.2.45. It's asking us for a username and password. Let's go ahead and try Cisco and Cisco. and we were able to successfully log in there. Let's go ahead and type quit, gets us out. And we can see that we did make our connection. We were able to do it successfully. Was the connection successful? Yes, it was. Which access list should be modified to prevent users from the internet to make FTP connections to the branch server? Okay, I'm going to minimize our internet PC user window. What we need to do is we want to block FTP, but we don't want to block everything that belongs to TCP, including the web stuff or any of the other TCP protocols. So we need to be able to block just port 21 of that layer 4 port. That means we need to do an extended list. Extended list goes as close to the source as possible. So that would mean it's an access control list here on HQ. So I'm going to go into HQ here. I'm going to go through and do a show access dash list command. It'll list out our access list here. We have 2 extended and 1 standard. If we remember, the extended ACL 101 is placed right here. And so that would be the ACL that you would want to apply, because we're looking at all inbound traffic coming in on HQ. That's the ACL we would want to do. Once again, that is access list 101. So which access list would we want? We would want to apply it to access list 101 on, and then we were on the HQ router. So that would be to deny FTP traffic, and to deny FTP traffic. Which statement or statements should be added to the access list to deny this traffic? Oh, so to this access list right here, we need to add in a statement that denies FTP traffic to our branch server of 192.168.2.45. Now, could be a couple of ways of doing that. If you wanted to get rid of denying here to our enterprise server of FTP, we could change this IP address right here. Probably not the best way to do it. Or we could add in a deny statement here between sequences 20 and 30, or somewhere in there, that would deny FTP traffic to the host. And so that's probably the best way to do that. And so, okay, we would need to add in the statement here of deny, and then we're TCP from anywhere, because once again, we're applying it to this list right here. So anything on the outside, this is an any. So we'd say any, and then destined for, and then once again, it's a specific IP address. So it'll be a host of this IP address. It'll be this exact IP address right here. So it's a host of 192.168.2.32, and then equal to FTP. So equal to FTP. You add that in before the permit statement. So add that in before the permit any statement. And then that will deny our traffic. Destined for our host of our branch server equal to FTP. That was Packet Tracer Lab 5.5.1 IP version 4 Access Control List Implementation Challenge. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.